So here are the notes for example 2b for 2.8 notes. So basically graphing polynomial functions. So here what we need to do is find the x and y-intercepts and any local max and mins of the following function. X to the fourth minus 6x cubed plus 3x squared plus 10x minus 3. So the first thing we are going to do is we're going to find the x-intercepts. And to find the x-intercepts, we are actually going to use our graphing calculator here. Now remember, if you do not have a graphing calculator, then you can always use Desmos to find your x-intercepts. So going to our graphing calculator, we go to y equals, and we plug in, so make sure you clear the following one. We have x to the fourth, then minus 6x cubed, plus 3x squared, plus 10x, minus 3. So I'm going to go ahead and go to Zoom Standard just to make sure my graph is in the standard window. So we go to Z Standard. Now notice here, right, we don't see the entire graph. So we do need to change our window so we can do that, okay? We'll do that in a little bit when we have to find any local max or mins. Now notice here how many times that the graph crosses the x-axis. It crosses 4 times. Now we could just look at basically our degree, and that tells us how many solutions. In this case, we should have 4 solutions, and if we look back at our graph, we get 4 real solutions. So remember, to find these solutions, we're going to go to second trace and then go to 0, so number 2. Now I'm going to find this leftmost 0, so I need to move my cursor over to the left bound. Remember, left bound means we're going to be on the left-hand side of our x-intercept, so that's going to be above the x-axis. I press enter once. Now my right bound, I go below the x-axis. I press enter again, and then press enter one more time. So here looks like one of my zeros is -1 point, and we'll round to 3 decimal places, so -1.137. Now here, even though this says e to the -12, -1 e to the -12, this just really means that if we moved our decimal over 12 places to the left, it would be very close to 0, okay? So that means one of our answers, and we're going to write it as an ordered pair, is -1 point, go back so I can remember, 37137, 0. Now we find the other 3. Go ahead and try to do the other 3 on your own, so you can make sure that you know how to do the keystrokes on the calculator. So make sure, go ahead and pause it, and either go to Desmos, or if you have your own graphing calculator, try it on your own. Okay, hopefully you tried it on your own and found the other 3 zeros. I'm going to show you how you would do it here. Okay, so once again, you go to second trace. We go to 0, and then I'm going into the middle here. So I need to be on the left-hand side of that x-intercept, and the left-hand side is below the x-axis, so I press enter. And then right bound would be above, so I press enter again, and then I press enter one more time. So this one looks like it's going to be 0.289. So that's going to be our second one. 0.289. And remember, write this as an ordered pair. Okay, now I find the other 2. So once again, I go to second trace, and then I go to number 2. Now to find my third 0, left bound means above the x-axis because that's on the left-hand side of our x-intercept. Then I go to the right bound, that means below, and then I go press enter one more time. And then here we have 1.816. So we'll write that down. So 1.816. And we write it as an ordered pair. And then our last one. So we go to our left bound. Now before doing that, we need to go second trace. Go to 0, so number 2 here. And then I move my cursor to be left bound. It's going to be basically below the x-axis. There we go. This is on the left-hand side of our x-intercept. Press enter. Then I go over and go up, and that'll be on my right bound. And then press enter one more time. And then this one will be 5.033. So those are all my zeros or x-intercepts for this problem. Now our next one is to find the y-intercept. Now for this, we really don't need to use a calculator at all to find the y-intercept. Because remember, all you have to do is plug in 0 in for x. So it's basically your constant. And our constant here is -3. So that means we have 0, -3 as our y-intercept. Okay. Now our next thing is our local max and mins. So let's first talk about local mins. That means that it's basically, it's the lowest point on the humps there, okay? So anytime you have a hump and it's at the lowest point, that is a local min. So let's look back at our graph. Now remember when we talked about this, I said we don't see the entire graph. Now this is where it becomes in hand where we do need to change the window so we can see all of our humps here. So I'm going to go to window, I'm going to change my y minimum, because that's what I need to, and I'll change it to -20. And then with that, I'll change my scale to 2. Now I'm just seeing if this is going to work. If not, we change it a little bit more. So still we don't see anything. So I'm going to go ahead and change it again. So I'm going to change my y minimum to, let's say, -40. There we go. And then I'm going to make my y scale 5. And then hopefully we can still see. We kind of still don't see it. So I'm once again going to change it probably to -50. And then let's graph it. There we go. So now we see all of basically our local mins and max. Now local mins, remember that's at the bottom of our humps. So if we look, we got 2 bottom humps. We got one here and one here. That means we have 2 local minimums. You can actually have more than one local max and minimum because we're localizing to a certain area of the graph. So to find both our mins, what we're going to do is go to second trace. And then we're going to go to number 3 for the minimum. Now I'm going to find this leftmost minimum. Remember, left bound means on the left-hand side of our point. So I need to move my cursor just somewhere on the left-hand side, press enter. And then I need to move it so it's on the right-hand side. So that would be my right bound, press enter. And then press enter one more time. And so it looks like our minimum here is at -0.57 and then -6.51. So we'll go ahead and write that. There we go. Good. But now realize that we have another minimum, so we need to find that. So we need to do that same type of stroke on our calculator to find the other one, and that's going to be on this right-hand side. So once again, I go to second trace, and I go to number 3, and then I'm going to move my cursor over. Now remember, left bound means on the left-hand side of this point. So I press enter, then I go over to go to the right bound. There we go. Press enter and press enter one more time. Here our function is at 3.96 and then -43.04. So I'll kind of scroll down here. So we have 3.96 and then our y value is -43.04. So now our last thing we have to do is find the local max. So we have to determine how many we have first, so we can find all of them. Let's go back to our graph. If we look here, we only have one that's at the top of a hump. So we really only have one local max. So to find this local max, we go to second trace, then we go to number 4, maximum. Remember, left bound means on the left-hand side of that maximum point. So I'm going to move my cursor over to the left a little bit, and then move my cursor over to the right for the right bound, and press enter one more time. And it looks like our local max is at 1.11, and then the y value is 5.11. And once again, we do write this as an ordered pair. Okay. So that's how you find x-intercepts, y-intercepts, local mins, and max using the graphing calculator. If you have any questions, make sure you email me or come in before or after school.